Yeah.
Good luck and good morning.
Good morning, all. So I will talk about Bluetooth smart or Bluetooth low energy man-in-the-middle attacks, and this is also present my framework I developed to perform this kind of attacks. So basically, I'm a senior researcher at CertiBIC. This is a cert, the cert of digital security, sister company of Econocom. I'm the head of research and development, so this is quite cool. And I focus on Bluetooth smart and Bluetooth low energy security since 2014. So it's been 2 years. I've been studying Bluetooth low energy and so on. So we are going to talk about the Bluetooth Smart 101. So for those of you who don't know about Bluetooth Smart or Bluetooth Low Energy, so it deals with all the basics. And then I will go with the main problems most researchers encounter when it comes to sniffing or intercepting Bluetooth smart communications. So we will be talking about why sniffing sucks, and then go on with the man-in-the-middle framework I've developed. And I've prepared some live demos. I hope they will work. It's very tricky to perform this kind of demos on stage, especially when it is based on Bluetooth smart or Bluetooth low energy protocol. So just we are going to start with some basics. So Bluetooth Smart or Bluetooth Low Energy Protocol, it's a subset of the Bluetooth 4 specifications. So you will find some kind of Bluetooth Classic and Bluetooth Low Energy in the specifications. So it was designed to allow low power devices to communicate with some kind of applications or other devices. It's lighter than the Bluetooth Classic, so it consumes less power, and it's very easy to implement Bluetooth low energy rather than the classic Bluetooth protocol. And of course, it's widely used in tiny embedded devices. So if you have some Fitbit or I don't know, even a smartphone, your smartphone is Bluetooth low energy enabled. So you can communicate with your Fitbit, or I don't know, maybe a tiny robot like this. So it's pretty cool. And a lot of smart devices use BtLE, I mean Bluetooth Smart Protocol. So a lot of people created since the last say 5 years, a lot of devices such as some padlocks, home alarm systems, and so on. So it's very, very widely used in these devices. The Bluetooth Smart Stack is very particular because it's based on the lower part of the stack on the same protocols that are used for the Bluetooth classic communication. So, but there is some differences. First of all, there is some kind of rules, specific rules implemented by the Bluetooth Smart Stack. So if you interact with some kind of devices, you can interact with peripherals. Peripherals are devices that accept connections, but they usually accept only one connection at a time. The central device is a device that connects to one or more peripherals. And when I'm going to talk about the Bluetooth low energy protocol, I'm also talk about Bluetooth Smart or BtLE or BLE. This is exactly the same. Bluetooth Smart is a protocol based on the 2.4 gigahertz baseband, the same as Wi-Fi and Bluetooth Classic, of course. And it allows simple communications through what they call the services and characteristics. Those services and characteristics are implemented in the GAP and GAP protocols. So I will talk about it later. It also uses frequency hopping spectrum. So it basically, this system of frequency hopping is implemented to avoid interferences. So I will deal with it in some later on, but this is pretty interesting, and this is why the sniffing doesn't work so well. And this protocol also provides encryption, so you can pair your devices and secure all the communications between, say, an application and a device. is a Bluetooth smart connection initiated? So first of all, the peripheral sends an advertising packet on one of 3 advertising channels. So in the baseband, you have 3 dedicated channels for advertising. So this packet is sent. This packet is catched by a central device. When this packet is catched, the central device sends a connection request, a connect request packet, to the peripheral, and then the peripheral starts the connection. So since this exact moment where the connection request is received, the peripheral and the central synchronize and start hopping from channel to channel. So basically, they just jump from one channel to another. So to perform this kind of channel hopping, they need to be very precise and have precise timing. Bluetooth Smart provides some security through the Security Manager protocol. This security enables encryption and also man-in-the-middle countermeasure, so it avoids man-in-the-middle, basically. How does it work? It's pretty simple. The initiator, in my slide here is the mobile phone, sends a pairing request to the device. Basically, the pairing request contains some very interesting information about the capabilities of the device. So it tells the device if the initiator has some kind of keyboard or a display or something like this. And the device sends a pairing response with the exact same information. If the device has some kind of keyboard or a display, it will be mentioned in the response. Based on these capabilities, they agree on a short-term key. This short-term key will be used to provide both devices with a long-term key. And this long-term key will be used then to secure all the communications. So this is a process. This process is only be done once when you pair your devices. And once it's done, both devices will use encryption, so you no longer you won't be able to intercept all the communication without this long-term key, and it's very difficult to crack this key. The GAP and GAT protocols are used to provide some services and characteristic features. So basically, services contains or expose many characteristics. Characteristics are basically some remote registers you can use to write data to and read data from. And you can also be notified or asked to be notified when the characteristic is modified. So this is a completely asynchronous process, and this is why BtLE or Bluetooth Smart is sometimes difficult to use or to when you develop some applications or create devices, because it's completely asynchronous. You have to handle a lot of callbacks and so on. So in terms of security, we are very interested in being able to sniff the communication between a smart application and a device, just to see what is sent and received from both parts. And until now, you generally use this kind of device to perform the sniffing. So this is a Bluetooth LED sniffer based on the Nordic Semiconductor chip, and this is fully proprietary. The code on this sniffer was developed by Nordic, and it's almost compatible with Wireshark. You have some kind of extension or dissector to install with Wireshark to handle all of this. So it's very cheap. This one costs around $30, and it's well, it almost works. You may know this one maybe better because it's the Ubertooth 1, which is a device able to intercept or sniff Bluetooth classic communications, but also Bluetooth smart communications. It's based exactly on the same mechanism for intercepting data from the Bluetooth smart protocol. But in fact, the great problem we face when it comes to sniffing or intercepting Bluetooth smart communications is that the advertising channels are located, are spread across the baseband. So we have the 37, 38, and 39 channel used for advertising. These channels are marked in orange in this slide. And you have to listen on all of these channels to intercept a connect request if you want to be able to follow the communication between two devices before they start frequency hopping. So you have to be lucky to intercept this kind of message. And especially when the 2.4 gigahertz band is not very noisy. If you have a lot of noise, the sniffer may catch some preambles that are not the correct preambles or not the expected ones. And it will try to decode the packets, but basically this is not a Bluetooth smart packet or so on. And it will lose, this will waste a lot of time for the sniffer to catch the real packets we are looking for. So this is why it's very difficult to sniff communications with this protocol, this Bluetooth Smart protocol. And this is also why researchers are looking for solutions such as Sami Kamkar that uses is DIY Faraday cage technology from IKEA. So it's maybe better with this kind of hack, but it's still difficult to intercept all the communications. And more of this is even more difficult to analyze the data intercepted on this protocol, because with a pcap you have to dissect all the packets. You don't have the clearly information you want. So at Digital Security we use a professional Faraday cage like this one to put the device in and analyze all the communications. But even with this one, we made some holes in it to put to make the cable go through. And even with these small holes, we have some noise inside the Faraday cage on the 2.4 gigahertz band. So it's even with that, this is sometimes difficult to isolate the device you want to analyze from all the external traffic. So I was looking for a solution, a way to avoid all of this problem in order to intercept all the information. So I thought about man-in-the-middle. This is clearly stated in the specification. You can perform man-in-the-middle on the Bluetooth Smart protocol. Well, what is not encrypted or when pairing is not used. So man-in-the-middle avoids a lot of things. It avoids sniffing for a connect request packet on the 3 advertising channels. So it's very easy. You create a dummy device, providing all the services and characteristics, and you wait for an initiator to connect to your device. So what's next? Encryption is not really a problem, since we are the device the central connects to. So we can handle the pairing and the encryption process with the device. Imagine this like an HTTP SSL proxy. This is exactly the same. The encryption is performed between the initiator and your proxy instead of the initiator and the target device. And it's also possible to spoof Bluetooth device address. This is a kind of MAC used for the Bluetooth protocol with a very specific USB adapter called based on the Cambridge Silicon Radio chip. So this is a cheap adapter, so very affordable, and it allows this kind of attack. And pairing is no more a problem, since we can pair any application or device with our dummy device. We control this dummy device, so it's very easy to pair with our device. So man-in-the-middle may be a solution to intercept all traffic and all communication between devices, BLE devices. So how does it work? First, I set up a central device. This central device will connect to the target. The point is, the target usually handles a single connection at a time. So once you're connected to the target will no longer advertise itself. So it's pretty cool, because you can spoof the target. If you spoof the MAC, you can make your dummy device that communicates with your central device. You can make this dummy device with the exact same Bluetooth address and advertise the same the same device with the same exact same services and characteristics. So it's pretty interesting. So you create a dummy device with the same profile, same characteristics and services, and you just wait for an initiator to connect to this dummy device. Once the initiator connects to your device, you can forward all the operations, all the GATT operations, and all the read and writes that are performed on the Bluetooth Smart protocol. And this is it. It's no more difficult. Well, almost. So I started developing this framework back in March of this year, and I had to develop it in Node.js. I'm not a great fan of Node.js, but this is the only language, development language, that I found that provides both features. The Noble and Belino libraries I base my tool on provide a way to create or emulate a device, and also a way to connect to a device. This is exactly what I needed when I started developing this. I also bought some standard BT4 adapters, USB adapters, for both central and dummy. And the communication between the central and dummy, if you remember, here between the two of them, is performed with WebSockets. So you can just put the central on the device, the dummy on the device, and they will communicate. So it's very easy to put, say, a Raspberry Pi in a Faraday cage and perform this kind of man in the middle. Also, it supports bonding with some kind of configuration. You have to install a specific version of BlueZid and a specific version of Linux kernel in order for this pairing and bonding to work. And I faced a lot of problems, especially timing issues, because it took some time for my central device to connect to a target. And the fact is, when you're trying to spoof your Bluetooth address, if your central device takes a lot of time to connect to the target device, then your smartphone with your application will connect to it before you will be able to create a proxy. So you miss all the connection and you miss all the data. So this was my first problem. And also the libraries my tool is based on had some drawbacks, because the guy who implemented this library did not create them to perform this kind of attacks. So I had to dive into the library code and to fix it. Both libraries, Noble and Belino, in this case, by some monkey patches. So it was kind of tricky, and consider it like a hack of these two libraries. So the architecture is the following. So we have a core, which is in fact the code that we create our dummy device, and the proxy, which acts like a central device and connect to the target one. I developed a lot of bindings to be able to communicate with the proxy without the Node.js part, by especially developing some kind of Python bindings in order to be able to communicate and to automate all the tests and all the attacks through Python rather than Node.js. I'm not a Node.js fan, as I said. And also, I developed a web UI, a web user interface, in order to be able to provide some kind of a nice feature, like the bulb suite, to be able to intercept all the communications. So the setup is really easy. Since it's Node.js, you can just install it with the npm. The web user interface looks like this. So it's very, very basic. It provides all the information, all the GATT operations, and also some other features. So with this tool, you will be able to intercept all the communication between a device and an application with a burp-like user interface. Well, it's far away from what burps provides, what burps features are, but the idea is there. And it also provides some kind of exports, so you can export your data intercepted. And as I said, there are some bindings for Node.js and Python 2 and 3. So it's pretty cool to use and to automate. One drawback I have with this framework is that you need two machines to make it work. Why two machines? Because the Linux kernel does not allow to create with the Node.js libraries. Does not allow to create both a central device and a peripheral device on the same machine. So you have to implement the central device on a specific kernel and use another kernel, so another machine, to implement the peripheral. And I made this in order to I use two machines and these two machines communicate with WebSockets, as I told you. For this, I need two Bluetooth 4 adapters. Especially, I'm using the one inside my laptop and another one in USB because of the VM I will be using, and it's based on Node version 4.3.0 and upper versions. The benefits of man-in-the-middle rather than sniffing: it works with any Bluetooth adapter. You can intercept every GET operations. It also supports bonding encryption. So instead of cracking the encryption based on some PCAP, you're intercepted with a Bluetooth. Then it's integrated in this framework, and it's compatible with the test you can make with a Faraday cage. You can put an agent in the Faraday cage that will forward all the communications. And BT address spoofing is possible. If you want to perfect the create dummy, you can abuse the fact that a device only supports a single connection at a time, and use this Cambridge Silicon radio adapters to spoof the device address. And in fact, when the device once you are connected to the device, you can just advertise the same device with the same Bluetooth address, because the device starts hopping from channel to channel except the advertising channels. So some kind of Python bindings and Node.js bindings. So it's pretty straightforward to implement on-the-fly data modifications. If you want to make some patch and replace, you can use some callbacks I provide in my framework. So for instance, here there is a on-before read callback with service characteristics and offset parameters. So you have just to check about the service UIDs and characteristic UIDs, and then send the response you want. So here I've implemented a battery level hooking system. So if you use this hook on a real device, it will show some variation of battery level. So first of all, you read the battery level, you get some kind of 100% battery level, and then 99, 98, and so on. We'll demo this later, but it's pretty interesting to see that we can modify on the fly all the data and modify the behavior of a device by just using this framework. So there are some node limitations. BtleJuice does not support long writes. This is a feature in the Bluetooth Smart protocol that allows writing more than 300 bytes. This is not widely used by the devices, because most of the devices relies on the features provided by Android and iOS, which are basically limited to 22 bytes of data. So for most applications, most devices, this won't be a problem to use BtleJuice. But sometimes, and I experienced it with some devices, you will be stuck because of this feature. So this is an improvement I'm working on to be able to handle this kind of long write. And of course, there is also an induced latency when you are using BtleJuice, because you intercept data from BTLE, then you transmit all of the stuff through WebSockets and back to BTLE and so on. Sometimes it takes not so much time, but it may be detected to determine if a kind of man-in-the-middle framework and BtleJuice, in fact, is used to intercept communications. But well, latency in Bluetooth Smart is kind of normal because devices are normally operating with low power, and sometimes it takes time for these devices to provide the required information if there is a read operation or write operation. So this is the origin of the framework. This is the framework itself, and I'm going to perform some live demos on it. I pray the demo gods all the night. Hoping this demos will go fine. And we will start with a very simple one about sniffing secrets. Since we are able to intercept communication between a smart application and a device, we will be able to intercept secrets. And I would target one of the well-known padlocks. This one has been presented at DEF CON this year. This is the Quick Lock, a smart padlock made in the US with all the security. It's advertised like this, and let's see what happens when we use this padlock with some kind of Android application. So I've set up all my stuff in the top of the screen. You have my my demo, all my demo script, and I will start BtleJuice. I have a nice VM right here. That runs BtleJuice proxy, the proxy part of the framework. It's connected on the host-only network. And I will connect to this here. So I just provide the IP address of my VM. So something like this. That's 56.1.2. And of course, the demo. Just wait a minute. I knew it would fail. Even in this morning, it's very particular. Well, so hopefully I have some backup videos. So let's start with the video. I'm very sorry. I'm going to. Well, I think the live demos won't work today. Well, anyway, let's start with this one. So it's basically the same setup. I have the Android phone on the right and all my stuff on the left. So what I'm going to do with this this padlock here is just putting some kind of interception. So I start the BtleJuice core system at the bottom, and the web interface at the top. So I'm just pushing the button on the padlock. The padlock shows up. I double click on the padlock to set up the proxy, and the proxy starts. I start my applications, and my applications will connect to the padlock and send a lot of information. So you can see that the GET operations are correctly intercepted. I have some read, write, and notifications. But if you look carefully, you will see a pattern, a very specific pattern with 1, 2, 3, 4, 5, 6, 7, 8. And it's not this pattern comes from the password I set on the padlock. So basically, the smart application just sends the PIN code used to unlock the padlock in clear text over BLE. So this is quite interesting, because if you have the same application, you can add this padlock with or pair this padlock with another smartphone and then open it. So this is very common for this kind of devices, but in fact, security is very poor for this padlock. If you are able to perform this kind of man-in-the-middle, a user may use this padlock, and if you are around performing this kind of attack, you just sniff the PIN code, and you may open it or unlock it later if this PIN code is the same at this moment. So this is pretty interesting to see that a lot of devices still send information in clear text. Well, still doesn't work. Or sometimes it's due to some rules. This is not the case. Well, anyway. So this is the quick lock. So this padlock sends all the data in clear text, and it's very easy to detect this kind of vulnerability using the framework. So another point is that the authentication of the padlock is based on the sole BG address. I mean, if you spoof the Bluetooth address of the padlock, this is very easy to intercept all the data. And this is the only check performed by this padlock to be able to authenticate performed by the application, sorry, to authenticate the padlock. So it's very easy to bypass. So we go on with a replay attack. Well, I think I will forget the live demos. And this morning it's will be very difficult to perform. But the replay attack may be performed on some kind of BtleJuice-enabled robot. So this is the Huawei MIP robot. And this is this robot here. Pretty nice. Well, Chinese one, and it's not very stable, but anyway. And this robot has some interesting features in it. I will show you. So back to the demo again. So this is my setup. I did some kind of a video of the robot at the end of the video. So it's exactly the same. I set up all my stuff with the BtleJuice core system and then the web interface. I select the Huawei device, starting the proxy. And besides, I launched the mobile application that came with this robot and start intercepting all the read and write operations performed by the smart application. Basically, this is very, very simple. There is only one service with one characteristic. So it's very easy to guess how the protocol works. And if you look at the operations, I try to replay some kind of some messages starting with 06, 06, and 2 bytes of data. Well, this one is just for me to have all the messages ready for the demo. But in fact, by replaying these messages, I was able to identify the correct message used to make the robot play sounds. And there are many sounds in this robot. And the first one I started was I don't know if the sound is okay. It's a test sound, just a simple bit made by the robot. And if you have a look at the second stock sound, so here it is. These sounds are not used by the robot itself or the application. So it's present inside the firmware, but not used. And I think this one fits exactly this morning because of the such an event yesterday. But anyway, so this is with this kind of tool, you can also perform replay attacks and go on with some kind of manual fuzzing. And this is very interesting to see what can be done with this. So that was for the Huawei. This robot is pretty interesting. So no authentication, because authentication was based on advertisement data. So this is the data sent in the advertising packet. So basically, anyone can spoof this. There are some undocumented features, which are the sounds that I managed to play, and this is possible to fuzz all the stuff with the BtleJuice. So this is quite interesting with this framework. But the fact is that I have implemented some kind of bindings for Python and Node.js, and it will be interesting to see if we can automate some attacks on other devices, much more interesting devices. So I started looking at this one. I don't know if you know what it is. So this is a blood glucose monitoring system. It is a medical device used by diabetics to monitor the glucose in the blood. And this device is made by a well-known vendor. And this is one of the first blood glucose monitoring system based on Bluetooth Smart. And this is now common. A lot of medical devices are switching from old protocols to Bluetooth protocol because it's supported by all your smartphones. So it's very easy to to interact with the smartphone and have access to the internet through the Bluetooth Smart protocol. So this one is a blood glucose monitoring system, and we can expect a lot of encryption, privacy from this kind of device. But as you will see, this is not the case for this one. So I set up an attack with my tool, with my framework. It requires some reverse engineering of the mobile applications to guess how the protocol really works based on the interception I made before. But this device sends measures to your smartphone, to your smart application. The smart application is connected to some e-health services online, and all the data is sent to these services. And there are doctors and physicists behind this that change the configuration of the medical devices in order for the patient to get wealthy. But this data sent by this device are not correctly encrypted, and in fact not really encrypted at all. So since there is absolutely no authentication, or almost no real authentication, it's possible to send false measures to your smart application and get these measures sent to the remote server that stores all the measures. So it's pretty interesting to see that we can automate all of this very easily. So I developed a script that intercepts all the required messages from the protocol and spoof all of this. So we are sending a lot of random values. So yeah, random vendor, I said. So we are sending a lot of spoof values. And since we can avoid the disconnection of the device, the application tries to gather a lot of information in a kind of loop. So I can send a lot of fake values to the smartphone application by pretending being the blood glucose monitoring system. So this is very fully random, and this is performed in a loop, and you see that all my script automates the whole process. So it's very it's like I don't know 30 or 40 lines of JavaScript in this case, because I use the Node.js API. But it's very easy to develop. The only thing you have to understand to perform this kind of attacks is the protocol itself, because most of the vendors implement a protocol over Bluetooth Smart or Bluetooth Low Energy. So once you get how the data is sent and received and how the protocol works, it's okay, you can perform this kind of attacks. So here it is. If you have a look at the graph of the measures, it's really weird because of this injection. Oops. Okay. So for this blood glucose monitoring system, there is an authentication based on Bluetooth address only. There is no strong authentication implemented, so it was very easy to fake this monitoring system. In fact, this is a very old protocol used in serial communications that has been ported to Bluetooth Low Energy. So it's a very old protocol with known weaknesses and some other vulnerabilities that has been ported to Bluetooth. And the fact is that in the old days, they were using a cable to link the two devices, your computer and the blood glucose monitoring system. But now it's performed over the air. So anybody can fake or pretend to be this blood glucose monitoring system and send random values or fake values that the same as I did here in this demo. So it's very easy to send fake records and to potentially help the patient that use this kind of device. So it's a great problem. About the countermeasures. So as I said, there is some timing issues induced by this tool. So from a device point of view, it's easy to detect if you're performing some kind of man-in-the-middle attack. So if you just measure the time needed to perform a read operation or write operation, you can detect some abnormal or something if something happens in this kind of operation. So you may detect this attack or this tool with this timing issue. And if your device keep the BLE or Bluetooth low energy connections active during a small amount of time, my tool needs to reconnect and reconnect again. And this is more difficult to perform interception in this specific scenario. It's very easier when the device stay active, and if you have to only connect once to the device, and it's okay. If you have to reconnect again and again, this is more difficult to intercept only information. And of course, if the device uses an application layer encryption combined with strong authentication, we are completely doomed here. We cannot do all of this interception stuff. So just to sum it up, BtleJuice as a security tool, you can use it to determine a device behavior. You can perform some kind of sniffing and data manipulation, can perform live replay attacks, can perform some kind of fuzzing, and it also supports bonding. So this is not really a problem. But the only thing is that the bonding would be made between the device and your smartphone, and your proxy, sorry, and not especially on the target device. If you plan to use it as an attack tool, it can bypass Bluetooth device address or some kind of MAC address authentication. It can be instrumented. So if you want to perform automated attacks, it's possible with this kind of tool. It requires only generic hardware, not Bluetooth or something like this. So it's very affordable, and but it needs two machines to work perfectly. And there are some limitations due to Noble and Bino libraries this tool is based on. So it's some problems I'm actually working on to improve this tool. So the future work for this tool is to solve the two-machine setup, which is a great problem to embed or to create a very tiny device that can perform this kind of man-in-the-middle attacks. And to improve user interface and bindings, of course. And I need more amount testing. So this tool is open source and is available on GitHub. I put the link in the slide. For those who are very interested by using this tool, I also set up a virtual machine, OVA file you can import and put in your virtual machine. If you are using some USB adapters, you can plug it into the VM, and you will be okay. So the URLs will be the
Questions will be outside.
Okay, no problem.
Thanks a lot, Damiel. If you have questions, you'll need to ask him in the hallway outside. We're out of time, unfortunately.
Okay, thank you.
Thank you very
much.
much.